Okay, we're going to add some vectors today. Come to think of it, that's what we did last time. But last time we were adding vectors, the way I put it was pictorially, you might say graphically, or by measurement, by using a ruler and protractor. And that's a good way to do it because, it's a nice way to really get your mind on what's happening so you can have images in your brain whether you draw them or not. But in this lesson, we want to get exact answers, not approximate answers. Exact answers. Now, actually, we saw at the end of the last lecture that if you happen to have your vector in a rectangular form, it's actually really kind of easy to add the darn things up. What you do is you take your x components, that's the x component, I guess you would call it v sub x component of the vector, and you add those up. 3 plus negative 2 is 1. And then you would take the y components, that's a y component, that's another y component, and you would add those up. 1 plus 2 is 3, so I'll go back to blue now. And so the answer is 1 comma 3. It's really that simple. If you've got your vectors in rectangular form, that's all you got to do. Now let me just kind of maybe prove that to you a little bit. So just sort of start making a grid here. So the vector 3 comma 1, what's that mean? It means two things. It means go in the x direction 3, but also go in the y direction 1. So if you go in the x direction 3 and the y direction 1, you end up, well, at the point 3 comma 1. And then when you draw that from where you started to where you ended, that would be the vector 3, 1. And then negative 2 comma 2, what's that one? That one would be, well, you have to go in the x direction negative 2, which means backwards, and then in the y direction positive 2, which means up there. If you started at the origin, you end up at the point negative 2 comma 2. And so that's the other vector. And so when you add those two vectors together, remember this idea called the parallelogram rule? So like you see this vector, how it's at that angle there? Well, I'm going to try to draw sort of the same angle here. And then you see this angle, this vector is at this angle here. Well, I'm going to try to draw more or less the same thing over here. And then here's where we start. You go across the middle of the parallelogram, and that would be, that's called the resultant. It's the answer. When you add those two vectors together, you get that red arrow, which we call a resultant. And wouldn't you know it, especially if I draw this accurately, it's got an x. In the x direction, you go 1, and in the y direction, you go 3. Ain't that something? It's nice. So rectangular form, groovy. Just go ahead and add the x's, add the y's. So that's it for that. Okay, part B. Given vectors in polar form. Well, here's what you're not going to do. You're not going to add 3 plus 2 to get 5. You're not going to add 20 plus 120 to get 140 degrees. That doesn't even make sense because 3 at an angle of 20 degrees is roughly the same as that vector there. Not the same, but it's roughly the same. And 2 at an angle of 120 is, very roughly the same as this angle there. And 5 at 140, where the heck is that? That's like out there someplace. So no, it doesn't work that way for vectors in polar form. So let's just kind of make a note to ourselves. Maybe a note in red would be good. Sure. Or maybe this fuchsia-ish color. You cannot add r's. That's an R. You cannot add r's and thetas separately. So please don't. Can't say that I've actually seen anyone do that yet, so that's good. But just make sure you don't even have that idea. Don't even have that idea. So, okay, since you can't do that, I suppose we could do it the same way as we were doing last time, which was to, ruler protractor. Could use ruler protractor. Or, here's another idea. I need a color. Give me a color. We could convert to rectangular. Because if we convert these to rectangular form, well, then we can just add those like we did in example 1. So, okay, now do you remember how to do that? There's some nice formulas we can use to get rectangular form. The x component would be, you take the r, this is the r, and you multiply it by the cosine of the theta. This is the theta, right? So let's get this out of the way. So all you have to do here is say, well, 3 angle 20 degrees, huh? well, the Vx would be 3 cosine 20 degrees, which we can work that out on a calculator. Oh, please tell me I have my calculator. Where's my calculator? Man, oh man. There it is. I found it. Okay, so 3 cosine 20 is what? 3 cosine 20, boom. 2.8191. I like to carry 5 sig figs in the middle of a calculation. You should too. And then the y component, the formula for y component, maybe I'll put it up here too, is r sine theta. We were playing with these, right? A couple lessons ago, I think. So r sine theta, so it's the r is that 3 there and sine 20 degrees. Sine 20 degrees, which is what now? 3 sine 20, bam! 1.0261. And that's what you do for that vector. And then we can take this vector, 2 at an angle of 120, and we do kind of the same thing. Vx is equal to 2 cosine of 120. So what is 2 cosine of 120? Tell me, Mr. Calculator. 2 cosine of 120 is, oh, negative 1. Perfect. And then for the y component, we would do the 2 sine of 120 degrees. What is it, Mr. Calculator? 2 sine of 120, boom. Boom. I said boom. 1.7321. 7321. So then to get your resultant, all we got to do is add up the x components. So the resultant then has an x component of, I add the 2.819 and a negative 1, and I get a 1.8191. And then over here, when I add this and this together, I get, what, 2 point something. 2 point, looks like a 7582. Oh, that's nice. Never had to carry anything. So there, we found it. That would be the answer. So when you add this and this together, you get this. Well, I don't know. We're not quite done really, are we? Because, look, they were so nice to give us polar form. Shouldn't we give them back polar form? Yeah, we should give them back polar form. So let's convert back to polar form. So there's 2 more formulas you got to remember here. What's the, we want the r and the theta. This is the Vx, this is the Vy. What we want is the r and the theta. So the r is, remember you do a Pythag with your Vx and your Vy basically. And I'll just plug the numbers in and do it. Let's see, 1.8191 squared plus 2.7582 squared. Okay, so that equals some big thing, but now I have to take the square root of the answer and get 3.3041, something like that. 3.3041. And then as for the theta, remember this formula. You do a shift tangent of the y over the x, which is the 2.7582 over the 1.8191. Okay, so shift tangent of 2.7582 divide by 1.8191, hit the old equals button, and I'm getting 56.6 degrees. So our final answer then would be more like if I use 3 sig figs now for the r, and then I use, well, I already rounded to 1 decimal place. So there. I like to round my angles back to 1 decimal place and my r's to 3 sig figs. Just a convention that I usually use. So there was a little bit of work involved here, eh? Because we had to first, these were in polar, and you can't add polars directly. You can add rectangular form directly, but not polar form. So what do? You get rectangular form. That way you can add directly. So we took the 3 at 20 degrees, we converted it into rectangular. We took the 2 at 120, converted it into rectangular. Then we were able to add up our rectangular components to get this and this. And then once we had our rectangular components of the resultant, the answer, we went back and converted to polar form. So remember, keep this formula handy, keep this formula handy, keep these 2 formulas handy. You're going to need them, especially in this section. Okay, so I think I only have 2 more examples, but they are important examples. So this one's an important example. It is an important example. Now let me see if I can convince you. Okay, so it's the same thing. We're given some vectors in polar form, and we want to add them up, which means first we should get the rectangular form. Now to organize my work, I like to do this. Pretend you're like an accountant, a bean counter or something, and say, okay, let's get out one of those green pads of paper with all the nice lines and stuff, and make a table. So vector, we've got a vector here, 64 at an angle of 105 degrees. We got another vector, 37 at an angle of 205 degrees. And then we're going to have the resultant. We're going to have to add these up somehow. But before we can do that, we're going to need to convert to, or you know what? Rather than label that vector, I think I'll label it this way. There's your polar form, and now we're going to make rectangular form. Okay, so there's the polar form. So that's, I guess you might call that vector 1, vector 2. I don't think I like the v1, v2 myself. I'm going to get rid of those. But that's vector 1, vector 2, and we're going to add those up to get a resultant. And the resultant, we will have to put the numbers right there, or we will anyway. So anyway, back to our mission. Convert those to rectangular form. So remember, for the x component, you do the r cosine theta. That's what you do, right? That's what you do. And so I'm going to be doing 64 cosine of 105. And then for the y component, I'm going to be doing 64 sine of 105. And if you want to make numbers out of those, you can. So 64 cosine 105 is like what? What is that? It's a negative 16 point, what do I got? 564. Again, I'm using 5 sig figs because I'm in the middle of a calculation. 64 sine 105, boom. I got a, what is this now? 61.819. Okay, fine. That was fun. Now you do the same thing with this vector. So r cosine theta, r sine theta. That's supposed to be an angle bracket. So what are we getting this time? Well, 37 cosine 205. Boom, 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 boom. I got negative 33.533. And then the 37 sine 205. Now I'm getting a negative 15.637. That's a 15. Okay, so now to get the resultant, I just add those two together and I add those two together. So the resultant, maybe I'll put like a bottom line here. Very accountant-like of me, isn't it? So negative 16.564 minus 33.533 gives me negative, what is this? 50.097. That's a 9. And then over here, 61.819, adding a negative 15.637 gets me to 46.182. And in some sense, you found the answer. I guess that's a lot of partial credit. That's the answer, except wait, we want to have rectangular form over here. So you have to do the r and the theta stuff. Now here's something to be aware of. To square a negative is to get a positive, right? So that means that this negative, really, we should have this parentheses here. Now, I've seen this happen a lot. Come on, you. I've seen this happen a lot. I'm going to show you the wrong answer first. I'm going to type negative 50.097. I'm going to square it. I'm going to add 46.182. I'm going to square it. I'm going to say equals. And then when I try to take the square root, I get error. And why is that? It's because I'm trying to take the square root of a negative. Well, why am I trying to take the square root of a negative? Because if you don't put that parentheses there, go back. If you don't put that parentheses there, your calculator thinks that this is a negative number. You got to be very careful about that. So when you plug it into the Pythag, my advice would be to do one of two things. If you like typing in the negative, then make absolutely sure you're using parentheses. You're putting the negative inside the parentheses and then squaring, because that'll make it positive. If you're like me, you just won't bother to type the negative. I'll just type 50.097, I'll square it, plus the 46.182, I'll square that. Now I'll take the square root of that answer. This is better. I'm getting a 68 point. And at this point, this is my final answer. No more calculations. So I'm just going to round back to 3 sig figs and get a 68.1. Okay, cool. Next, theta. So remember, the formula is to do a shift tangent of the y over the x. Make sure you put the y over the x. And here, you don't have a choice to ignore the negative. You have to type the negative. So 46.182, I'm going to divide that by a negative 50.097. Right? Right. And now I'm going to hit equals, and then I'm going to go shift tangent of the answer. Boom. I get negative 42, and if I round back now, it's 0.7 degrees. Negative 42.7 degrees. Now, what do you think of this move? Does that look like a good move to you? That's a terrible move. That's a terrible move. Why is that a terrible move? Well, you got to remember that this formula requires care. You have to be careful with this. You have to, this goes back to Biff's two-answer theorem. Whenever you use a shift trig function, shift sine, shift cosine, shift tangent, there's two answers. Your calculator gives you one of them, but sometimes the answer you want is the other one. So in this case, we want the other one. How do I know? Well, I'll show you how I know. Because this is our answer, right? It's a negative 50, which means back here someplace and up here. It's a negative 50, right? That's roughly a negative 50 and a positive 46. It's over there. It's in the second quadrant. The vector is up here someplace. Well, where's this angle? It's not pointing up there. This angle is pointing down here. That's a negative 42.7. So remember, with the tangent, sometimes you have to add 180 to get the real angle, because this is exactly the other way. So you have to add the 180 to that. So let's see. 180 plus a negative 42.7, boom. So I've got a 137.3. Now that's the angle we want to put in here. 137.3 degrees. Okay. Please be very, very careful about that. Be careful about that. I showed you two things to be careful about. The negative inside the square root thing there, right? Make sure you either use parentheses or just don't even bother, because you're squaring it. It's going to go positive anyway, so why enter it? With the shift tangent, just make real sure you check. Should I be adding 180? I just took a shift tangent. Should I be adding 180? Well, you can look here and say, well, I'm expecting a vector that goes up into the second quadrant. That's not pointing into the second quadrant, so yeah, I have to add 180 to it. Okay, so that's a good problem. Oh, that has to go on the test, doesn't it? Doesn't it have to? It has to. Or maybe this one. Okay, so what do we got here? We got Biff. He's heading his personal aviation device, 50 miles an hour at north 60 east. Okay, so we have these kinds of angles now. Notice north 60 east, you're not going to say theta is 60. No, you're not. Theta is not 60. In fact, let's figure out what theta is. North 60 east, huh? Okay, what is that? Well, if north is here and east is here, so north rotates 60 towards the east. Here's north, rotate 60 towards the east, right? You get over here. That's what north 60 east means. It means that way. Now, as a standard angle, standard position angle, I should say, you always measure from due east. So theta in standard position is 30 degrees. And that's the angle you're going to use in the r cosine theta, r sine theta stuff. That's the angle you got to use, standard position. Okay, well, that's cool. So now let's start making our table, shall we? So remember, I'm going to put, I guess I'll put the vector first. I'll have a vector column. And the first vector is the personal aviation device. And I can put it in polar form now because we know it's going 50 miles an hour. That's the r. And we just figured out that the theta is 30 degrees. Cool. And you know that we'll be converting that to rectangular soon. Though not quite yet. Let's get the wind going, because we also got to add the wind in. Now the wind, in a steady crosswind. Hey, how fast is the crosswind? I remember how fast the crosswind is supposed to be. It's supposed to be 8 miles an hour. So whoops, I forgot to add that in there. It's a good thing this isn't your homework, huh? So anyway, I'm sorry. I was supposed to put 8 miles an hour in there. So he's in a steady 8 mile an hour crosswind. So, okay, so the wind has an R, so to speak, of 8. And which angle is it? I need a standard position angle. North 10 west. Now, you got to be careful about north 10 west because, okay, here's north, here's west. So north, go 10 to the west would be, you know, this way. That would be a 10-degree angle here. That would be north 10 west. And you got to be careful because this is wind we're talking about. And the wind is coming from the direction of north 10 west. Whenever they say north wind, they mean the wind is coming out of the north, not that it's blowing towards the north. So which way is the wind blowing? It's actually blowing... Okay, something got blipped there, but I think we can recover. I was trying to say that here's north 10 west. It's up there, right? But when we say that the wind is coming from that direction, because that's how they say it, a north wind means the wind is coming from the north. It's actually blowing towards the south. It's coming out of the north. That's what a north wind means. So the wind is actually pushing on his aviation device in this direction down here. So I guess you can kind of tell that, you know, by symmetry, that would still be a 10-degree angle. But standard position is measured from the positive x-axis, and so the question is, what is that angle? Notice that would have to be a negative 80 degrees. It's 80 degrees, all right, but we're rotating in the negative direction there. Clockwise is a negative standard position direction, so negative 80 degrees. Okay, now we're ready to continue with our stuff here. Now I'm going to show you something. Remember last time I said, well, the x component is 50 cosine 30, and the y component is 50 sine 30. And then I worked out the numbers over here. Well, you could take a shortcut. Now, if you would like to work out these numbers, go ahead. But you don't really need to work out those numbers because all we're going to be doing is adding these things anyway. So continuing with the wind, this is 8 cosine of negative 80 degrees. And this is 8 sine of negative 80 degrees. So what I'm trying to say is to get the resultant, I can just kind of type all of that in my calculator, hit plus, type all of that in my calculator, hit equals, and then I'll get my answer down here. So I don't have to take time to write down intermediate numbers over there. Nah, I'll just type it all in. Just be careful. So 50 cosine 30, close my parentheses, plus 8 cosine of negative 80, close my parentheses, equals, I've got 44.690. I'm using 5 sig figs because I'm in the middle of a calculation. I'm still using 5. Over here on the y component side, I'm going to add the 50 sine of 30, close my parentheses, plus 8 sine of negative 80, close my parentheses, equals. And this is giving me a positive 17.122. Remember, in some sense, you just found the answer. The only problem is it's not the answer in correct form. We'd much rather have polar form. So we got to go over there and get polar form. So let's see now here. To do the R, all you really got to do is take that 44.690, square it, 17.122, square that, add your 2 squared results, and then take a square root. And you get 44.690 squared. Did I answer that right? Oh, look at me try to make a mistake. Okay. I tried to make a mistake, but I caught myself. 44.690 squared plus, what do I got? 17.122 squared. Bam. Oh, square root button. Don't forget the square root button. Square root of the answer. Bam-o. 47 point, and I'm going to round back to 3 now because it's my final answer. So this would be the resultant, or in this case, we have a better name for the resultant, his true speed and direction. So he's really going 47.9 miles an hour. So the wind is slowing him down a little bit, it looks like. Even though it's, well, if it's slowing him down, that must mean that he's partly going into the wind. Not straight into the wind, but partly into the wind. And then the angle would be, remember we got to do the shift tangent thing. So you take the y component over the x component, 17.122 divided by 44.69 equals shift tangent answer equals, and I got a 20 point, it's 20.96. So if I round that to 1 decimal place, that's going to become a 21.0 degrees. And there's my best answer right there. Now, do I have to add 180? No, I don't have to add 180. Why not? Because where's 20 degrees? It's like this way, right? And notice I've got a positive x component and a positive y component. So yeah, I must be in the first quadrant. So yeah, I don't have to add 180. So yeah, I'm done the lecture. Wow, cool. So okay, it's only 4 examples, but if I gave you more examples, they would just be the same thing, the same exact process. So if you feel like you want another example, what I would do is I would just try this again right now. Just try it again. See if you can remember all the steps. Or try this one again. See if you can remember all the steps and how it goes. The basic overall idea, if you've got vectors in polar form, convert them to rectangular, add your rectangular components, get your answer, but then convert your rectangular answer back into a polar form answer. Cool.